Welcome to API World 2021. It's my pleasure to introduce your next speaker, Toshish Jawale, CTO and co-founder of Symbol.ai. Toshish, will you please join me on screen?
Hey Joe, thank you so much for introduction. Awesome. Okay, hello everyone. I'm Toshish, CTO co-founder of Symbol.ai, and in today's session, I'm going to walk you through um, with um, with some of the trade-offs and nuances of what does it take to build a conversation intelligence application or extend your existing communication applications to have additional conversation AI or conversation intelligence capabilities built inside it, and different trade-offs of what does it mean to go to market, how to go live, and what is the what are the different options and how they evolve based on your specific needs. So first things first, when you talk about conversation intelligence, there is a there is a lot of confusion that I see on day-to-day basis in the industry. People sometimes think conversational intelligence and conversation intelligence are one and the same things. Technically, they should be, but they are not. That's just how industry has evolved now. So typically, conversational intelligence is more on the side of intelligent technologies that allow you to talk to machines or understand when you talk to machines and respond back. So typical examples of this is chatbots or virtual assistants like Siri, Alexa, and the different variation of the similar thing is typically also called conversational AI. The same thing, but just multiple terminologies. And then there is a different angle called conversation intelligence, which is more about just intelligence about conversations rather than how to have a conversation with human or machine. So conversation intelligence is more about understanding what is happening in existing conversations that are already in progress or has happened before. And another variation of that, sometimes also referred to as conversation AI. They sound so similar, so just wanted to make sure early on that we are going to focusing more on conversation intelligence and not conversational in this session at least. Now, conversations, right? Like I was saying, two types when it comes to spatial intelligence. When human beings just talk to each other, human to human conversations, or human talking to a machine like Siri or Alexa, or just chatting with chatbots, or even traditional systems like IVRs and so on. So any setting where human is talking to machine and machine is responding back is one type of intelligence. And the another one is human to human, which is where the conversation intelligence plays major role. So examples of human conversation which you would want to put intelligence in are typically um, critical conversations such as sales calls or customer care calls, interviews, even critical brainstorming sessions, or just in general casual talks as well, if it makes sense, right? So those are just two buckets that the technology has evolved right now. And uh, talking about human conversations, so the main key differentiation of the technology that is required to bring value out of human to human conversations as opposed to human to machine conversations, right? Is that the technology needs to cater to the chaotic nature of how human beings just talk, right? And it's just the nature of it. Human conversations are very natural. They are chaotic by nature of being natural. There is no fixed workflow around it, and and it's not very formal, right? So there is a lot of context understanding required to make sense out of what people are talking about. And the typical examples where most of the valuable conversations happen are just listed here. Very valuable calls, like sales calls, to even just the brainstorming discussions internally in the company, and so on. So these are the human conversations where conversation intelligence as a whole ecosystem surrounds around. And there are mainly two modes of intelligence when you think about conversation intelligence applied on human conversations. One is while the conversation is actually going on, during the conversation, right? And you would and intelligence can help facilitate conversation better, help people focus on the actual discussion or meeting rather than doing multitasking and getting distracted, bring more productivity, automatically perform few actions for people in the conversation, suggest them something while they are in the call. So, few things of those could be: imagine there is a customer care agent serving a customer, and based on what they are talking about, the problem or whatever concerns they are talking about, the system is able to understand that in real time and suggest the agent to what typical next action they can do or actually do then for agent. That would reduce the cost to serve the customer. One agent can do more efficient and more product can be more productive in serving customers, and obviously the time to serve customer is directly proportional to the satisfaction of customer when it comes to customer care use case, for example. So these kind of things can be very, very impactful. This is just one example of what can be done in during conversation, but these things can get more and more sophisticated even in during conversation scenarios. And then once the conversation is over, you could have just the record of it. You can summarize it in form of minutes of meeting. You can do various types of analytics on top of it. You can even do historic analysis of conversation to find out trends on what conversations are working well, what are not. For example, you might want to know which type of sales agents or customer care agents have higher success rate, analyze, dissect their conversation, learn from it, those kind of things. And you could even just facilitate and follow up based on certain things. So these are typical use cases where you would want to apply intelligence after the conversation is over. And so these two main buckets of use cases, and each of those require different types of characteristics in your intelligence stack. For example, if you're talking about the real-time use cases for during conversation use cases, you want fast inference system. The latency has to be low. It needs to maintain the context as the conversation is going. It cannot be just one single bulk processing, which comes with its own challenges, not just on in intelligence side, but also being able to stream the audio video components uh, and get the feedback from the intelligence stack in real time. All those are challenges that come with just serving these kind of use cases. And obviously asynchronous, the scalability, bulk processing, turnaround time, how fast can you do all of that. Those kind of things are another parameters which are more non-functional that we don't think about usually when we think about just the intelligence piece, but those are very real factors that play important role when we think about these two buckets in any type of intelligence, but more specifically in conversation intelligence too. Now, this is a very common mistake, or rather, very common uh, clarification that many people don't pay a lot of attention to, and initially in their journey of building these things. And it's very important to understand that conversations, by its nature, are not like documents. Documents are very well thought well articulated piece of information, and it's written after putting a lot of thoughts and a lot of iterations, and that's why the information content of document is very structured and is very relevant to it, right? Documents have very high quotient of information, whereas conversations don't. The patterns through which the human, when people talk, there are few parts of conversation which are extreme information in those parts of conversation, whereas there is a small talk going on, or there is just irrelevant conversation. People get confused when they talk, people argue with each other, and there is a lot going on in conversation as opposed to documents. So any tech stack or intelligence stack that is built with the assumption of processing documents is not really a right tech stack to be used on conversation. And many people don't pay a lot of attention to this fact, and then uh, and later in their journey they realize the limitations of why things are falling apart, why it's not performing well, and things like that. So that's just a clarification that I wanted to put it out there and make sure that if in case this wasn't something that you have given thought to, it's important to make this distinction very clear when figuring out how to start this journey, or if you're already on this journey. Now, few basic things about different characteristics of what conversations are. These are just very simple and very abstract um, characteristics of conversation, but they give us little good perspective on what conversations are, and it puts us in a perspective of what a technology should be doing to cater to conversations, especially human conversations. Very simple thing. They're temporal. They move forward in time dimension, and it's not something that you can just simply apply non-sequential techniques to process. So you have to know that they are moving in time. Uh, it's very conceptual. When people talk, they already have a lot of understanding of certain concepts they're talking about, or they establish the conceptual understanding within the conversation. So for example, if I'm talking about a baseball game, I already know what baseball game is, and all the participants in the conversation already have that conceptual understanding of what baseball is, what game is. And in case if it is a completely new concept that somebody is introducing, they define those concepts in the conversation. So it's very important that conversation has a well established conceptual understanding, and concept is a key element that drives conversations. Conversations has causal nature to it, which means that when people are talking, they are trying to describe certain things, certain concepts. They are trying to talk about the potential actions, the events that happened during the course of that, or any actions they took from the past, or they're sharing their experiences. And everything that they are explaining or talking about or arguing about surrounds around the causality. Everything is related, something happens and it causes an effect. And that relationship is something that is very critical when it comes to getting value out of conversation. The system has to understand the causality in the conversation to be able to do that. Natural conversations are natural. I think I talked about it early on. It's not a formally written document. It's very naturally flowing dialogue. It's driven by creativity, the thinking process, the exploration aspect. So it's not something that has already been done, and it's not a summary of certain thing. It's the actual natural dialogue between people. Conversation are contextual. I think I touched upon it a little bit. When people talk, there is a predefined context about it. And if it is not, usually the context is established within the conversation. People talk about the relevant things that has a causal impact on certain actions or concepts they're trying to talk about. And ability to relate those predefined concepts and their causal understanding and relate them back in the context of what is happening in the conversation right now or at given point is extremely critical aspect of understanding, or at least how humans understand conversation. um, and they are relational, so there are a lot of things that happen there are different entities people talk about, there are concepts that are being talked about, there are factual data, people take actions on that, and all of these things are related to each other. That's why those things are relevant and contextually relevant to that conversation. So these are just few main factors what makes conversations how they are today, and these are the factors that come that are critical when a system is supposed to help users inside the conversations or inside those meetings with different types of problems or the limitations they have with just being just being in the conversation, or just to save time and find more intelligent insights out of those conversations. Now that we have this established right here, this is how a typical ML system looks like, right? That's how the build cycle is. Typically, there is a bunch of training data that one need to gather. The quality of data has to be really good to make sure the system works well. The architecture of model has to cater to the problem you're solving. And typically, this training data and this model is very limited to just a single use case. In certain cases, maybe few use cases, and then going through multiple iterations of training, and then testing, benchmarking, and then doing keep doing it again to improve the accuracy and performance of what model is doing, measure the relevance of it. Typically, all of those test and benchmark activities are done by a human being, a data scientist, or a machine learning engineer. And then once we reach to a point where all stakeholders are happy, test results look good, we typically then integrate and deploy and integrate that model into the actual application that user is going to use, right? And if you pay attention to this, this step one and step two are extremely, um, these are extremely time consuming and expensive activities. There is a lot, much human energy needs to be invested in these two steps to be able to just simply integrate it with the model. And this is a major problem in adoption of AI systems today across the board, not just in conversational AI, but this problem of adoption needs to be solved for a rapid adoption of any kind of AI technology. And that's where we are going to spend some time today to understand why exactly is this required, how how can we solve it, and I'm going to share some of our experiences at symbol.ai. How did we solve it, and how do we um, do uh, do the how did we are going to take one example of one of the problems we solved, and we are going to look at how did we solve that and what's the end result of that, and what are the possibilities, and how it helps you to think about choosing your battles when you are trying to build a machine learning system, especially in conversational intelligence. So ideally, this should simply look like this, right? Ideally, in an ideal world, you should be just able to integrate your app with the choice of model, and the model should take care of all these other aspects of figuring out what data to use, what uh, testing to do, what benchmarking to do. And in certain use cases, you might even want it to happen in real time. So we're going to explore the challenges, the goods, bads, uglies of these entire aspects, and we're going to take one example uh, of this, and I'm going to show you a little demonstration of the actual usage of that model. So um, this is how ideally your adoption cycle should look like, right? You want to get your version 1 out as quickly as possible. Imagine you're just starting to build an application, or you're just expanding your existing application to have CI in it. Then ideally you should be just able to use out of the box APIs or SDKs or tools which are pretty much able to generalize across multiple domains and use cases, and get it out quickly. And then the most critical part of product building in any kind of product building is to iterate and make it better and better, to make sure you provide the best experience to your users. And then you focus your energy on iteration, and then you figure out more specifics that are relevant to your use case, your industry, your domain, and then you keep iterating that. And then you continuously have your system learn from the constantly changing behavior of how conversations are evolving in that specific use case or space. For example, if it is a customer care call, it's not going to be same forever. It's going to evolve. New products will come up, new types of issues will come up, and it's a constant activity to keep up with that. And you can't just keep training all the time new models with everything, because it's expensive and there is too much investment to be done in there. And then you keep iterating on your feature set, uh, just like this. You start with another angle, another feature, and then you keep doing the same loop around that. Now, one way to solve this problem is to do all of this in a real-time fashion, right? So I'm going to use a real-time or during conversation use case as a test case or the case study here to talk about it. Now let's imagine we are doing that. One way to do that is to do all these three cycles: train, benchmark, test, and deploy in real time, and have your application adapt to it based on what is going on in conversation or few recent conversations. And it does need to do all these things in this case without any human intervention. So that makes things a little harder. The system needs to adapt to constantly changing requirements as the conversation progresses, and it needs to train and test and deploy very very fast, right? It cannot wait for, typically it takes days or weeks, if not months, to do all of those. And it only becomes harder and harder as the data and complexity of the problem increases when you are building those models. So, and obviously the inferences has to be fast, which is, believe it or not, relatively simpler problem than adapting in real time quickly. So in such system, this is how that would typically happen. The model itself would be able to train itself by choosing the right data that your system is gathering. It should train itself within the span of few seconds or minutes based on how time sensitive that adaptation needs to be. And then it should just be able to deploy it on the fly so that your application can keep drawing inferences from the newly learned information and adapted information learned by model. And all of this needs to happen simultaneously. Now, like we saw, it has to train really, really fast, which is very hard thing to achieve. And it's almost impossible to achieve when the problems become very complex. You can do this for simpler statistical models that can do that. In fact, there are techniques to do that at a much more narrow problem. But language problems are typically not like that, and they are typically very heavy duty deep learning models, and it becomes very very, very hard to do all this entire cycle, all the steps in this entire cycle within that time frame. So, and then typically these kind of models require huge amount of data for training, so that it can generalize across the newly learned as well as the old learning it has. Now, this is not a good approach if your application is very time sensitive. For example, if you're in a customer care call and you want to build a system that can help agent in real time within the span of a second or two, to solve the customer problems or give them suggestions or automatically trigger workflows or fill in the form automatically for agents so that they can focus more on helping customer rather than asking them to hold all the time, which clearly is the leading depreciation factor for CSAT. So this is something you can't do. That you could do these kind of things for little less time sensitive systems like recommendation system. For example, you could do that if you have a e-commerce site and you want to learn based on user behavior, which can happen. The training can happen every 1 hour, and then your models can adapt to it uh, on hourly windows. But when it comes to a time frame of seconds or minutes, it's especially in the language specific problems, it's not a doable approach. However, this is a successful approach that is being used in a lot of different areas. So just to summarize, main challenges with this is the training, testing, deployment done manually is very, very time sensitive, time intensive, and resource intensive. Data quality needs to be manually made sure, and if you screw up the data quality, your model can actually degrade its own performance as well. So there is a very huge risk factor in automating this entire pipeline. And it's not possible to reuse the same model for other use cases because these models tend to get very specialized in a certain area. And when you use them on even very close but a different type of use case for exact same task, they don't generalize. And real-time shifting of context is almost impossible when we are talking about conversations as a use case in this case. So for that, at Symbol, we adopted something called a zero-shot learning. It's something that the first paper around zero-shot learning came out in 2018, and it's a technique that allows a machine learning system to learn from very few data samples, or in some cases, even no data samples, to perform the task. And the system and this entire concept of zero shot learning is to build a machine learning system that can solve the generalization problem. So it needs to be able to generalize without actually seeing enough amount of data, or in some cases even no data. So that's what the concept of zero shot learning is. So what's going to happen in this case is that as you have requirement of adapting to changing requirements in an ongoing conversation, not even a conversation that happened yesterday or an hour back, the live conversation, you can completely skip training, testing, and deployment phase here. So the existing model by its architecture itself can adapt to the changes in the context that's happening in the conversation. And the model can then generalize by simply how the conversation is changing. Um, and um, and this entire phase to learn what needs to be changed is very fast. It can even happen in few milliseconds, if not seconds. And the inference time remains the same because we are not really, zero shot doesn't really change anything in how inferences are drawn. Well, there are few changes, but not major ones, which is why you can leverage techniques like zero-shot learning in conversation intelligence space. And I'm going to show you the real example of one of the symbol offering that leverages this technique, and we'll see how it can be used directly in a real use case. Um, so this is just to explain a concept of zero shot learning. This is a simple example of animal recognition model. So let's say you are building an animal recognition model, provide it a picture, it tells you what model it is. And let's say this model has never seen zebra in its training phase at all. It only came across horse, which is the closest to what zebra is. But it was trained with additional knowledge about what animals look in picture versus their actual description the of the animal. And the system in this case can draw inference from its uh, uh, textual descriptions of animals and its knowledge contained in the model, which is embedded as part of training, and generalize it by looking at the horse. So it can see that, okay, this animal looks incredibly similar to horse, except few characteristics or few features, and the similar features like horse, but with black and white stripes, and it extracts that knowledge from its textual understanding, and it can generalize and draw conclusion that this has to be zebra. And that's the kind of problem zero shot learning solves. And I'm just using animal recognition as example because it's easy to explain, but the similar concept applies in the conversation intelligence, which I'm going to talk about. So just to refresh this, this is how this will look like in this model. You just have few samples that you provide to model in real time, and the model establishes context around that based on its existing knowledge. And then you can really start using it in the matter of milliseconds, and you can keep doing this for multiple use cases. You can spawn multiple such contexts as the conversation progresses for multiple conversations, and so on. And you can keep doing simultaneously as model draws inferences. Now, you avoid obviously the manual training, testing, deployment cycles required. The model adapts to the specific requirements of how conversation is changing. It establishes very specific context based on the specific requirements of what conversation is at that point, and it happens very fast. The same model can serve multiple types of learning contexts. So you can apply the same model in various different use cases, and at the same time also generalize enough to adapt to the constantly changing context of conversation. And very few examples are required to actually establish the context. It's not so it reduces the uh, data problem altogether, and it works great in such time sensitive use cases. So real time conversation intelligence, something like this that can adapt based on conversation in very uh, latency sensitive manner in milliseconds. This is a really good fit in such kind of use cases. So um, coming to this, so this is just a very high level approach of how it does in general, how zero shot learning achieves it. This is just one of the architecture, probably the most simplest one. It uses the embedding based approach. So what you see here, you provide it with some input data if you have some. Like for example, here the example shows that there have been instances where somebody is talking about trying to apply for a loan, not having enough money to start a business, things like that. And it takes maybe a couple of such examples. It does its own feature extraction thing. It models it into a dimensional feature vector so that it can work seamlessly with the knowledge embedding, which is this neural net. This is a projection of the actual knowledge base based on the features that we just encountered in the conversation in this case. And then it has some additional attribute vector, which it does additional loss analysis in real time and draws inferences. So this entire thing, typically in traditional machine learning systems, this happens in the training phase, and the zero shot learning removes the need of having that training phase and do the actual loss analysis, the feature extraction and projection of it through the existing knowledge embedding. Makes it very powerful to solve this kind of problem. um, Now, at Symbol, we use this in something called as trackers. So if you pay attention to this box right here, something called tracker, that is the feature that uses zero shot learning behind the scene. So I'm going to show you the actual working example of this. But before that, so that you can understand how Symbol in general looks and you can relate to that example. In general, Symbol API would accept anything like streaming audio, a telephone call, or just a recorded file, or just textual representation of conversation, right from email chat to even just the pre-built transcriptions, and so on. And then Symbol would process it in real time if it is a streaming or telephony call, and it can do all of this in real time on it, including trackers, where we are going to look at in this upcoming example. So we are going to use trackers plus streaming API in this example I'm going to show you. So trackers are nothing but um, uh, they provide users to track anything they want in conversation just by few examples. And so you don't really have to gather a lot of data just because you wanted to check that if somebody needs a loan or not, for example, in this case. It can simply just have a couple of examples like that, and it can immediately understand and gather the context around it and set that context for further inferences, that okay, this conversation is about need of money, applying loan, and those kind of things. So it generalizes the concepts, it understands the causal relationship between what applying loan means and versus sorry, what need of money to loan means, and what are the relational aspects of it from its knowledge embedding. And the streaming API, like I said, lets you stream audio of the live call or meeting over a WebSocket channel, and it also sends you back any real-time events that, in this case, trackers might be detecting to actually draw the inferences. So that's what this is going to be about. So here, I have a video that I'm gonna play. I'm gonna mute the video so that it doesn't it doesn't sound weird. But I'm gonna talk over as I play the video to show you what's happening and how it's working, and whatever we talked about around zero shot learning, how it's making um, decisions behind the scene. Now, if you look at this is just a sample code or sample application using streaming API. And if you see here, we are just, whenever the connection is open, we are just initializing connection by sending start request, and we are sending a sample tracker to detect if somebody is talking about any financial hardships, right? And there are just few examples, actually only three examples here for us that we have put here to. So things like when somebody say I am not able to pay my bills, or I'm behind my payments, or I'm not able to make any payments, these are the kind of things we would want to detect, and we think this is how we want to define when somebody is going through financial hardship. Now, what's going to happen is, as soon as this request goes back to Symbol, it's going to initialize a context for this specific tracker, and it will keep looking for certain instances like this over the course of entire conversation. And as soon as it detects something, so for the demonstration purposes, to keep these things this demo simple, we have put together a condition right here. If you see right here, this condition is simply to check that if there is a financial hardship detected, at any given point, uh, it would uh, it would simply modify the request on the fly to add additional tracker for additional detection of if they are also looking for a loan or if they have already applied for a loan, and this is going to happen right away in real time in few milliseconds, and that's what this demo will show you. By leveraging zero shot learning, we are able to just adapt to the change of context of whatever we detected and what we would like to do based on what we are detecting in real time in matters of seconds. And this example uses very hard coded example so that I can show you how much they can generalize. But in real scenarios, all of this can be simply driven by the actual contents of conversation. So I'm going to skip forward to the point where we run this demo. So here we have run the demo. Uh, we are talking, this person is now talking about um, just talking around it. So I'm going to skip forward a little bit. And right here, as they're talking about it, they said something around having a hard time to pay the bills. And if you see, the tracker was detected immediately in real time about the hardships of financial hardships, and it would show you that they actually talked about having hard time to pay my bill. This wasn't something that we established context around when we created tracker. The actual um, thing was about not being able to pay the bill or something like that right here, but it generalizes and it understands this is just another way of saying the same thing, and it could even expand with more examples, right? So now as soon as this happened, immediately if you see right here in the bottom, it added a new tracker to the real-time stream, and now it's going to look for if now they talk about applying for a loan, and as soon as they talked about it, immediately it detected the next one, the condition got fired, and we detected, and again this was not exactly how it was configured in the actual tracker, but it was able to generalize it enough in real time uh, to detect it. And so this was a very simple example of how you can build a real-time use cases, even trigger actions, show suggestions, or just record this and show this entire thing as analytics. Or there are multiple different things you can do along with this. And symbols trackers allow you to do that with the power of zero-shot learning. So this was just an example around it. Um, and that was pretty much about my session. If there are any questions, I'd be happy to answer. If not, I can chat offline or in another one-on-one discussions later as well.
Thank you again, Toshish, for your presentation. Thank you all for joining in today. And as we wrap up day 2 of API World and AI Dev World, please make sure to continue to come to our different sessions. And we want to say thank you again for attending and hope to see you soon. All right, see you.
Bye.